Distinguished ladies and gentlemen, it's a great pleasure to be here today and to present you a little bit the Dutch approach on dealing with water management. I titled it Collaborative Approach for the Design of Resilient Cities. But basically it's all about living with water and facing the future. This is the Netherlands, as you know, a small country. 2/3 of the country is at or below sea level. I myself, for instance, I live 6.2 meters below sea level, and I hardly realize. We only can live like that if it wouldn't be for all the pumps, the storage we have created for the ditches and canals, the large infrastructure works that you see here, the Delta works, and the cities which cope with it. But the situation may become different towards the future. Our institute, I work for the National Water Research Institute. We support the Dutch government at the national and regional levels with water management. We deal with all these issues as what you will see in a moment, although I try to focus a bit on this adaptive approach. We are known also by the software systems, more and more open source, freeware, you name it. On this slide, on this picture to the right, you see the largest wave flume in the world, where we can generate waves of 5 meters or more, dealing with tsunamis, storm surges, you name it. Basically, to check on the strength of our infrastructure, protective infrastructure in the Netherlands. Software is capturing our know-how. Whatever we do in the Netherlands or abroad, at the end ends up in our software systems. And we use it for specialist consultancy work, for knowledge sharing, capacity building, training programs all over the globe. We have special software days for that, soon to come in Delft, in Bangkok, in Singapore, in Bangladesh, I believe. We also carry out research with these software systems. On the lower left, you see augmented reality. You shape it with your hands and the computer takes over. But most important, we use software to collaborate with teams all over the globe to make the software even stronger. As mentioned, the title of my presentation is a collaborative approach for the design of resilient cities. We cannot and we should not do it alone. We need to create ownership. We need to get to smooth implementations. And that's where I would like to demonstrate today the way we do it in the Netherlands with 2 new software developments. One we call the adaptation support tool, and the other we call Circle. It's all about cascading effects of critical infrastructure due to floods. What you see here is the closure of the Rotterdam harbor area, the largest port in Europe, the gateway to northwestern Europe, and very important in terms of protecting our city of Rotterdam and a substantial part of the GDP coming from that area. Adaptation also means that we look towards the future, the uncertain future, in terms of climate change, sea level rise, and what to do with infrastructure like this, normally designed with a lifespan of 50 to 100 years. This may not be working at that time anymore. This was designed to close once every 10 years. With 75 centimeters of sea level rise, we already have to close it 10 times per year. And with 1.5 meter sea level rise, we even have to close it more often. And then it becomes very inconvenient because it starts affecting our economy. So we're now already thinking ahead to what to do when sea level rise is accelerating with this kind of infrastructure. Do we have something in place which can replace it? First, adaptation. Adaptation is basically dealing with a lot of different aspects. We need to face climate change leading to increased rainfall intensity. We deal with increase in temperature, sea level rise, drought. We had a very serious drought last year, quite unexpected, but still with a large impact. We also deal with uncertainties in relation to population growth, urbanization, and land use changes, reduced infiltration and increased runoff. The urban heat island effect, not to forget, with all these cities growing, we see quite a big impact over there. And very important, not only for your region and deltas in the world, but also for the Netherlands, subsidence. We pump out water from deep towards sea level, but we pump out from deep peatlands. And peatlands, we maintain a certain groundwater level to allow for farmers and their cattle to make use of it. That means that by just reducing the ground level, the peat oxidizes and subsidence occurs. And this is quite a big issue in the Netherlands nowadays because it's even faster than sea level rise. So cities, that's basically my talk here, are designed for current and past conditions, but they need a retrofit. We need to ensure that they can also deal with all these future uncertainties. So for flooding, for heat stress, for drought, we would like to maximize on the livability in those cities, urban regeneration, the health potential, the sustainable economic development. And in existing cities, climate adaptation involves many stakeholders, what you will see in a moment. And you need to do it together with all of them. So co-creation of solutions is part of a stakeholder creation. This AST tool, the Adaptive Support Tool, was designed in a kind of GIS environment where we could sit all around the touch table on the screen, running different strategies and dealing with different scenarios. So it comes in the middle with the GIS, to the left with all sorts of measures, to the right with the results as translated in storage capacity, heat reduction, return time factor, evapotranspiration, groundwater recharge, cooling areas, but also impacts on water quality, nutrient reduction, solving pollutants, pathogens, and the cost, of course, the construction cost of all those measures, and the maintenance. In the database you can work with, there are some 70 to 100 different measures, which you can just plug in different parts of the GIS system. Each measure is described like this is a bioswale, do it, it works like this. But we should realize one thing, by just designing those measures, there is a sort of paradigm shift, especially in the Netherlands, but we sense more and more all over the globe. From fighting against water, we move to living with water. And from hard engineering, civil engineering, more and more to nature-based solutions. Building with nature is a concept which we now apply all over the globe. So from grey solutions to blue-green solutions, coming with different pros and cons. Less space, a dike, more space, no dike, etc. These urban nature-based solutions can be applied to small cities, the concept we have been discussing here also earlier. And they can be very effective. They serve more purposes. They can be effective in climate adaptation. They have additional effects like creation of recreational areas, nature development, and they add function to greenery in cities. So in practice, nowadays, we apply both soft and hard engineering solutions. We say in the Netherlands, hardware necessary, software possible. I'll give you an example. This is Utrecht in the center of the Netherlands. We had to work with the municipality in the most downtown area, pretty much paved area, where the ambition was more green, climate resilient, and a healthy urban environment. With substantial rainfall, we get flooding in that specific part. So we had to address what to do with flooding issues when they pop up. What can we do? So we used this tool to work together with the different stakeholders in finding solutions for this specific area. These are some pictures highlighting the area. It all starts off with understanding the system, understanding the water balance. Something comes in, something goes out, something stays in between. And if we can play around with these different flows, we can work towards more resilience. And that's basically what we did. With this AST tool, we were plugging in different measures, each with different consequences in terms of cost, in terms of impact. On the left side you see the measures, on the right side you see the output. And then we were just considering different alternatives. Full green development, so we were only considering the green solution from the database, and then we received the storage capacity of something like 15,600 cubic meters. If it was high urban density, so basically business as usual, we only had a storage capacity of 12,000 cubic meters. If we try to maximize on the storage, not considering the green aspects and the cost aspects, we could even come to 19,500 cubic meters. So you can visualize what the consequences of different strategies are, and you can all do it together. You can just make a decision, this is what I like to have in my street or in my district. And this is how it works. So the examples so far in the Netherlands show that co-creation really works. It leads to designs that are supported by the stakeholders. It positions also the different stakeholders. You understand better what they feel is important in their specific area. Most of the times the solutions are very location specific and you have to do more. But the discussions focus on opportunities and benefits. That's a very sound way of doing it. At the end, it pays off. We use it now at different levels in the whole planning sequence. In the problem analysis, we often work towards a better understanding of the system, using tools like Deltares, you'll see in a moment. Exploring different adaptation options we do with this GIS kind of environment, and then for the detailed analysis, we go back to the hydraulic tools. That was the first one, I'll come back to that later on. Then, the other one, Circle, it's all about cascading domino effects of floods on critical infrastructure. Critical infrastructure, as specified by the European Commission, means an asset system of part thereof which is essential for the maintenance of vital societal functions, health, safety, security, economic, social well-being, people, etc. And the disruption and destruction of which would have a significant impact in a member state. So critical infrastructure is the clockwork that makes society tick. Over the past decades, we have seen an increasing frequency and intensity of extreme climatic events. Circle now helps to understand the situation, how stakeholders make decisions together, and have all these different utility owners, relative stakeholders in terms of infrastructure work together and share data and know-how. This is an example of Europe. All the light is there except for Italy. This was a blackout in 2003 for 72 hours with a huge socio-economic impact. This is the same in your country, the typhoon Morakot in 2009. With a lot of disruption, with a lot of socio-economic impact, casualties. This is the flood in Thailand in 2011. Altogether some $46 billion in terms of damage, more than 800 casualties, huge impact. What do all these different events have in common? Usually they start off as a small event, but they have large consequences. The urban centers are usually most affected. And there are events with a single cause, but in most cases it's a combination of causes, and you have to deal with it. This is an example of a deep boulder in the Netherlands with a small breach in the embankment. We make hundreds of these sorts of simulations in the Netherlands, and in no time the entire boulder is inundated, affecting all the infrastructure, all the utilities. in no time we cannot reach the hospital anymore, or the pumps do not work, the telecommunications doesn't work anymore. This is what you will see in a moment.
Over the past decades, the number of natural disasters has increased significantly due to climate change and socio-economic developments, such as the rapid urbanization of delta regions. These disasters also have a major impact on critical infrastructures. At Deltares, we work with government agencies, network operators, and other stakeholders across the globe, each facing the challenge to protect critical infrastructures from natural disasters, and each with a wealth of knowledge and experience, but unable to solve these complex problems alone. What if we could bring these stakeholders together and help them learn from their shared knowledge and experience? This is why we've developed Circle. Circle is a touch table application and a centerpiece of our collaborative modeling workshop. The Circle workshop is helping stakeholders to understand the complex relations between critical infrastructures. These relations, or causal links, can be investigated and visualized even without very detailed information. Instead, Circle uses open data and our own Deltares models in combination with the causal links supplied by the workshop participants to analyze and visualize the impact of cascading effects on critical infrastructures. The results are presented to the participants. Together with our Deltares experts, participants are encouraged to examine different adaptation strategies in order to increase resilience. The rapid visualization of the Circle tool provides valuable insights and helps to understand the complexity of cascading effects. Moreover, the collaborative nature of the Circle workshop encourages further collaboration between workshop participants as they move together towards a more resilient future.
I'll now give you an example how it could work out for the city. It's the city of Amsterdam in the Netherlands, where we have simulated a storm event 100 years ago with the infrastructure of today.
Over the past...
So the city of Amsterdam, we focus in this application on the northern part of the city, which looked at that time like this, hardly any infrastructure of course, older areas, like we have 4,000 of them in the Netherlands. This was the event, serious flooding at the time. And now we assume that a situation like that could occur today. So we have two breaches in our dike that time to the southern sea. The first thing we did was we brought all the relevant stakeholders in one room. And normally they don't share data with each other. But soon they start realizing that by sharing data, they could carry out their job much better. If you know at what level of inundation you cannot have access to a certain place, then you can make a plan on that. If there is 20 centimeter inundation on a highway, you cannot reach the hospital, well, you have a big problem. So they need to know from each other at what time do the pumps not work anymore, etc. So you will get this demonstration now for Amsterdam, but all these relations at 20 centimeters, at 30 centimeters, at 40 centimeters, this is happening, are just applied. This is the situation. You see two dike breaches. First, the substations for electricity caused outages, then the fire station was affected. Then more substations failed. The emergency communication network could only run for 8 hours. The main roads were flooded. How could we evacuate people from a certain area? Etc., etc. From one comes the other. We use this tool as a calamity exercise with all these relevant decision makers, and that appears to be extremely useful. But even more important is that it's not only working during calamities, it also serves excellently as a planning tool. Where to plan your hospital, how should your highway be elevated, where to put your pumps, etc. And this is how we use it nowadays. And that it could happen as of today was shown in 2015 when there was a large power outage in Amsterdam in a certain part, leading to trains not working, Schiphol airport not functioning, flooding on the street, etc. So you have to be ready, you have to be practicing all these sorts of different situations. We made it available to the community online. You can play with it yourself, you can set up these exercises, but as I said earlier, it needs a good system understanding up front. When there is no internet available, we also made a kind of non-digital circle game, which has been played at many different locations in the world already and was very helpful. So Circle as a tool, additional to this sport tool, helps to create awareness, it gives you the overview of what is relevant and what is less relevant. It stimulates collaboration. It is an excellent tool for planning, for decision making, and it prioritizes your actions. What to do first, what next. So in conclusion, small impacts have large consequences and are often difficult to identify. You need to, well, consider all sorts of what-if scenarios. What if it happens here? What if it happens there? Where? How? Unfortunately, and that not only is applicable to the Netherlands, we have little to no experience in critical infrastructure failure, while it is so important to keep society running. Now we face climate change with more extreme patterns. Are we prepared for that? Can we just study it with tools like this? And the likelihood is that the failures increase with increasing complexity of our cities. Our cities become larger, more dense, more pavement, you name it. And even worse, in the next 30 years, more infrastructure will be built and built from the beginning of industrialization. So we really need to be ready to save our cities, to do something to face all these future uncertainties. Awareness of this and working with people leads to increased resilience. But most important is work together, collaborative approach. So these are tools perfect for disaster management, perfect for planning. And I always say, but it's common knowledge, if you fail to plan, you plan to fail. I finish with the simulation of Tjitte, which we did with some local partners, where the system understanding is there. Up to you now the challenge to work together with this adaptation support tool, work together with the circle, and to get an understanding of where you plan your next activities and how you protect the current infrastructure. Jesse, thank you so much for your